adding and subtracting polynomials. Polynomials, adding and subtracting, and right down here we have a few definitions. A polynomial is a monomial or sum of monomials. So a monomial means it's one term. So when you have all these numbers and letters next to each other, they're multiplying. That actually puts them together as one term. A binomial would be two terms. Okay, sum means we combine it. Okay, so the combination of, not always just adding, it could be subtracting. And trinomial means three terms together. So now we're going to find each sum or difference of these examples. And in class, I may alter which ones that we actually perform. So just to give you all a heads up. So this has got addition in between. So that's a +1 right there. And what do we know about +1? When we multiply it or distribute it, it doesn't do anything. So I'm going to go straight to combining my like terms right here. Remember, you combine the ones that have the same last name. So 4x plus 3x is 7x. -5 plus 6, or 6 minus 5 is 1. And that would be your answer. So you are just simplifying here. This one has a negative in between. Okay, so that's a -1. So with that, before we do anything, PEMDAS tells us we have to get rid of the parentheses. So we have to distribute this -1 to both things behind it, because this right here is multiply. So -1 times 4x squared is -4x squared. -1 times +3 is -3y squared. And I'm okay if you guys actually don't rewrite that. So I'm going to erase it and show you guys how I would prefer doing it and how I personally do it. I take this negative and I give it to both of them nice, big, and pronounced, just like that, to where you sure can't miss it. You know that it's there. Can't miss it because it keeps on having my screen come up. So now they're both negatives. So now I'm going to combine them. I'm going to remind myself that this is a 1. And this is a 1 as well, because that's a common thing we forget. So who has the same last name as +1? -4. Who has the same last name as this +1? -3. And you're just going to combine the shapes. 1 minus 4 is -3x squared. 1 minus 3 is -2y squared. So you don't do anything with the exponents on the variables. You just look at the coefficients. I generally don't do this one in class, but we will go on ahead and do it. It's a +1, so 1 times anything does not make a difference. So I'm simply going to combine like terms. I have a 3x squared minus 3x squared, xy squared, and then I have this. That's a 1. I want to remind myself, and that's a -1. Okay, good to know. So 3 minus 3 is 0. Okay, then I have -5 minus 5 is -10. Be careful there. So if I owe one person $5 and I owe another person $5, I owe $10. Then we have 1 minus 1, which is also a 0. So those first two, the cloud and the square, actually end up canceling out. Last example right here, you have that -1, so you're going to have to distribute it to everything. That's going to become a -2x squared, a +8, and a -2y squared. So who has the same last name as 6? That would be +2. And notice I am circling and squaring the operation in front of it. That tells me how to combine it. Do I add it or do I subtract it? Then I have 12 and +8. Then I'm going to have this little +4 over here and this -2. So then I'm going to go combine them, and I like to cross them out as I go when there's so many of them. 6, is that? Oh, that was a minus, wasn't it? I messed up on that. That shouldn't have been a plus. That should have been a big old minus. That was that 1 threw me off. I shouldn't have drawn the 1. So that's a negative. Goodness, guys. That is a -2x squared. 6 minus 2 is 4x squared. Okay. Then I have 12 plus 8 is 20xy. So notice we're not really worried about the variables. Then I have 4 minus 2, because remember it went to a minus, is 2y squared. So these were just combining like terms. That's all we're doing, is we're combining like terms. You just have to be careful of those parentheses. Next, P represents the measure of the perimeter. Find the measure of the other side or sides. So I would like to ask first, what is perimeter? We've actually talked about it a lot in our last unit. Perimeter is adding all the sides, okay, or the sum of all the sides, okay? So generally, I like to come over here and do a little bit of an example. I like to ask y'all this. This is what most students respond. If this is 5, this is 4, and this is unknown, and I tell y'all that the perimeter is 12, how do y'all do that problem? Most students tell me, well, Miss, I add these two together, so 5 plus 4 is 9, and then I subtract that from the perimeter, and that gives me a 3. So we're going to do this other problem over here the exact same way. We are going to add these two together. We're going to add these two together. Let me take those circles off so it doesn't confuse us with our order of operations or our combining like terms. So I'm going to add these two together, and then I'm going to subtract it from the total. So I'm actually going to write that down. Add, then subtract from total. So these are all positives, and I'm adding them, so that's really, really nice. I can just leave it simple, and I can say 2x has the same last name as this 1x. Okay, and that's going to give me 3x. And then I can say 2 has the same last name as minus 3, which is negative 1y. So I'm going to take this amount right here, and I have to subtract it from the total. So I'm going to take this, and I'm going to do a different color now. And from the total, I'm going to subtract this. And if you notice, it tells me that I'm going to have to distribute that negative to each thing in the parentheses. So that 3 is going to become a negative, and this 1 is going to become a positive. And then I'm going to combine my like terms. 5 minus 3 is a 2x. 2 plus 1 is a 3y. So that would be our missing side. We did it the exact same way as we did these easy numbers over here. Just took it up a step. Next, it wants us to find the total area given the area of each of its parts. So I've given y'all this option over here to rewrite it, but I particularly do not rewrite it. I'm just going to look at it. I'm going to solve it, okay? I'm going to remind myself that this is 1 and this is 1. I'm going to go look along. All right, so 3x squared has the same last name as 1x squared and the same last name as 6x squared. And then 1x does not have the same last name as anybody, and then minus 2. So those are just going to stay like that. So I'm combining my squares. 3 plus 1 is 4, plus 6 is 10. That would be a 10x squared. And then 1x stays the same, minus 2. So we just combined them. We just added them together. Now we're going to see it in the context of word problems. And we're probably going to break these up a little bit in class, but we'll do this first one. The length of a rectangle in terms of x is 5x squared plus 2x plus 1. And its width is 3x plus 1. What is the perimeter of this rectangle? So as a reminder, perimeter is add all the sides. So I'm going to write myself out a visual over here because I'm a visual person. And plus I'm adding, which means I can just circle them on the problem itself. So this length is this, and the width is this. Write them both times so you do not forget. So right here, since it's adding, I can just combine them all. I don't have to do anything special. So I'm going to come over here and say, who has the same last name as 3? That would be 2, 3, and 2. Who has the same last name as 1? All the 1s. And then this problem has its own little last name over here, the x squared, which is actually going to come first in proper form. So I'm going to put these two together. 5 and 5 is 10x squared. So this is just combining like terms. Plus 3, 4, 5, 6, 7, 8, 9, 10x plus 4. So I've just combined them together. That is all I have done. I really like writing it up there because I feel like it helps me I can go ahead and take this after I see the visual of my length and width. I can just take it and combine them within the same problem. Don't have to rewrite anything. Number 8. In the year 1999, the average cost of a car would be modeled by the equation C equals negative 8t squared plus 9,500, where t is the number of years since 1999. By the year 2008, the average cost had changed, so it could be modeled by the equation C equals negative 15t squared plus 10,000. Weird, but okay. Find the average and the costs for a car, find the difference in the average between 2008 and 1999. So you're going to take 2008 and subtract the amount for 1999. So my 2008 amount is this one right here. This is the bigger one, so it's going to come first. So negative 15t squared plus 10,000 minus, and you need to put it in parentheses because it's more than one term, negative 8t squared plus 9,500. Now, look at this, and we have a big flag here. We have this minus, and this minus changes everything behind it. It makes everything the opposite. So that negative 8 is going to become a positive, and this positive 9,500 is going to become a negative. We're then going to combine our like terms. Okay. So I have a negative 15 and a minus 8, and then 10,000 minus 9,500. So negative 15 plus 8 is negative 7t squared, and 10,000 minus 9,500 is 500. So this is the answer. This is the difference between the 2 years. So the depreciation, if you will. And it is a minus. That works out well. Now we're going to go to number 9. The measurements of the side of a triangle in terms of x are 5x squared plus 2x plus 1. X squared plus 1 and 6x minus 3. What is the perimeter? A reminder again that the perimeter is adding all the sides. So we have our 3 sides right here. So I'm going to go ahead and come down here and label it. Here's my triangle. And I'm going to label it. Doesn't matter which side you label. It's not to scale. We're just writing it out. Then you have 6x minus 3 and then x squared. It doesn't say which one is which. And it says perimeter, so I'm going to add all the sides. And I know when I'm adding, it's not going to change any of my signs or anything like that. So I can just go straight to adding. And I'm going to do it right here. I'm not going to rewrite this problem. I'm just going to use what I got. So this is a 1. And I'm going to square that. And it has the same last name as that. Then I have that positive 1. So those are just the numbers by themselves, the constants, because they never change. And then I have the plus 2x. Notice I'm circling what's in front of it. So now let's combine them, all my squares. 1 plus 5 is 6x squared. And then 6x plus 2x is 8x. And then 1 plus 1 is 2. Minus 3 is negative 1. So this would be the perimeter. It's weird, we want a number, but that would be the perimeter of our triangle. We have one more problem, and it is similar to number 8, but I'm going to go ahead and work through it. It says, in the year 1988, the average cost of a laptop computer could be modeled by the equation C equals negative 4t squared plus 1,700, where t is the number of years since 1988. By the year 2006, the average cost had changed, so it could be modeled by the equation C equals negative 10t squared plus t. Find the difference in the average cost for a laptop computer between 2006 and 1988. We know that difference is subtract. Let's find the difference. So 2006 comes first, which is this one right here. So I'm going to do my negative 10t squared plus t minus, and I have to put it in parentheses, negative 4t squared plus 1,700. And I'm going to do this in a different color just so that we see it a little bit better. So when I do negative times a negative, that makes that 4t a positive, and it makes that 1,700 a negative. Now I'm going to go combine my like terms. Who has the same last name as negative 10? Positive 4. Who has the same last name as this little 1t over here? Nobody, actually. He's kind of by himself. And then we have our 1,700. Okay? So negative 10 plus 4 is a negative 6t squared. This little 1t is by himself, and it's okay if you write the 1 minus 1,700. Remember, if they don't go with anybody, you don't force them with somebody else's family. You make them stay where they are.